Okay, everyone, so I'm going to start doing the full solutions to these four IB questions. The paper 2 one I'm just going to leave for you to try on your own because it's really nice and straightforward. You're just pointing out transformations. It's a paper 2 question, so you don't have to graph this by hand. It's just asking you for the intervals when one function's above the other. And this can be done doing just plotting both equations, seeing their points of intersection, and then seeing the intervals when one has a greater value than the other within this given domain, right? Just be careful to set your window of your graphing calculator to match the domain over there. So I'm not going to go through the solution for that. Worst case scenario, if it's confusing, I can definitely do it on Thursday when we see each other again. But I'm going to go to number 7 here. So for number 7 says the function f is defined by f of x is equal to e to the power of x squared minus 2x minus 15. So now we're just finding the straightforward first derivative. So take a minute, try it, and then just unpause the video so you can see the solution. Okay, so getting straight into our solution, I'm just going to copy our parent function here just so we have it. It's number 7, paper 1. Oh, paper 1. Oh, let's see. Just making sure you can see it decently clear. My pen's also running out of ink, so it's not just the camera. There we go. So it's paper 1, and we have f of x is equal to e to the power of x squared minus 2x minus, I believe that's 15. Oh boy, 15 or 1.5? It's 1.5. So there we go. Sorry for the issue with the printer, because I also am having a bit of trouble seeing the decimal there, but you can tell because the two numbers are separated. So for a, nice and straightforward, we know that the derivative of e of x is just e of x again, but because we don't just have x on its own, we actually have the function, we also have to take the derivative of our exponent. So what this just becomes is the derivative up here, so 2x minus 2 multiplied by the exact same expression, e of x squared minus 2x minus 1.5. Right? And we're already done. There's nothing really special to do here. This is our final answer. If you really want to, you can factor out the 2, but both answers are algebraically equivalent. So let's just get straight on into B. So it says that y is equal to f of x over x minus 1. You're given that y is equal to f of x has a local minimum at x is equal to a, where a is greater than 1. Find the value of a. So whenever I hear the phrase local minimum, I'm thinking, hey, my first derivative has to be equal to 0. So I just need to derive again. Unfortunately, we can't just take the answer from our numerator. We have to do quotient rule because now we have our parent function divided by x minus 1, but that's not too bad. So we have here the derivative of y with respect to x is equal to, applying our quotient rule, x minus 1. 1 second here, I'm just going to switch pens because this one's running out of ink. Okay, times 2 and x minus 1 times e to the x squared minus 2x minus 1.5, right? Very similar to like a typical IB style question. We have our previous answer here included here. So that's basically why they got us to do part A, to help us out with the solution to B. Okay, and then of course minus, we have our, well, derivative of our denominator, x minus 1 is just going to be 1, multiplied by e to the power of x squared minus 2x minus 1.5. Okay, and then, oops, sorry, close the big bracket, all divided by x minus 1 all squared. Okay, and now that we're at this point, we can't simplify it too much because it's not like both terms have x minus 1, so I could factor it out and either lower the power of my, or sorry, lower the exponent of my denominator or get rid of it entirely, but they do have both of this in common, right? I've got e to the power of x squared minus 2x minus 1.5, so I can factor that out. So my first derivative, and I'm just going to stay consistent with the notation in the question. So even though here I use Leibniz notation, I'm just going to write the y prime is equal to, what do I have here? 2 times x minus 1 squared, because that bracket pops up twice, minus 1 over x minus 1 squared, and then I can factor out the e to the x squared minus 2x minus 1.5 that they both have in common. And now I'm just going to simplify the numerator up here in my fraction as much as I can by expanding. What do I have here? 2x squared minus 4x, plus 2 minus 1 over x minus 1 squared, copying over e to the x squared minus 2x minus 1.5, and then finally just grouping my two constants over here to give me my final answer of y prime is equal to 2x squared minus 4x plus 1 over x minus 1 squared and e to the x squared minus 2x minus 1.5. Okay? And now we need to see when, so we have a local min, right? That was given us in the question, right? Because that's what we're looking for. When y prime is equal to 0. But we're also given another piece of information, if I recall. Let me go back here, where x is equal to a and a is greater than 1. That helps us out because we have to look at all the factors in our question. We have to look at the numerator up here, we have to look at the denominator here, and the denominator here. So, some notes. This, the e to the x squared minus 2x minus 1.5, is never going to give me a value of 0, right? Worst case scenario is either this gets ridiculously big, in which case it's not 0. If it becomes ridiculously small, or even 0 itself, e to the power of 0 just gives me 1. So again, can't produce a local minimum. And if it's negative, again, it's going to produce a very like 1 over a very large number, so it'll give me a very small number, but again, it won't give me 0. So this is not a factor that I have to consider when I'm looking for my critical numbers. Down here, I also don't have to consider, what do I have here? X could be 1, but then that wouldn't be when my first derivative is equal to 0. This would be when it's undefined, so I can disregard this as well. I only have to look at when 2x squared minus 4x plus 1 is equal to 0. And that I can just solve with my quadratic formula, right? So I get, what, minus b, so 4 plus minus the square root of 16 minus 4 times a times c over 2a, so 2 times 2. Now, let's see how well I can simplify past midnight. 4 plus minus the square root of 16 minus 8. So 16 minus 8 is just root 8 over 4. And just trying to simplify, what can I do here? Unfortunately, this isn't a 16, so it's not like I can get rid of the 4, but I can turn this into 4 plus minus 2 root 2 over 4. So this becomes 1 plus minus, oh my gosh, root 2 over 2. Don't know why it took me so long to think of that. But I've got my two solutions here, so our minimum occurs for those two values. Okay, 1 plus 2 root 2, 1 minus 2 root 2. Okay, so hopefully that made sense. Again, it just comes down to doing our first derivative, looking at our three potential factors that could yield a local minima. The denominator is disregarded because that's when the first derivative is not 0, it's undefined. This expression here can never be 0, so it can never be taken into consideration as a critical number. Critical number, that specifically produces a minimum. We're only looking at, this simplified expression right here. Okay? So, move on to the next video when you're ready for the second question.